Hey guys, Edward from ERM Bikes. We've gone from electric motorcycles to e-bikes to e-scooters to the golf carts to everything in between. So now we're starting into agricultural and rural farm equipment and stock equipment. So we are looking at this Polaris Ranger EV, so originally electric, like my 2007, 2010 Zeros and Vectrixes. So they're all restorations from out of date or corrupted or broken electric vehicle battery systems or control systems. This one has a good a good controller which will accept lithium polymer. I'm using 100 amp hour lithium polymer cells. They're slightly different chemistry, but let's just go for lithium polymer because that's what most people understand. And banking them in parallels of 4 and then putting them in series of 8 to get me to 16 to get me to 48 volts. The original battery is a golf cart style battery with a self-watering system. You can see them down here. I'll give you a bit of a run through them in a second. And they are the second or third, I believe, series to go in here, and they keep not working out or lasting very long. So we're converting it to lithium, and it'll be a Renology 12 to 48 volt trickle charger mounted on from a solar panel on the roof, and a inverter charger which will be mounted in the rear under the tray or under the bonnet depending on where the wiring cabling goes, and that'll be charging off of a solar grid and will allow 48 volt to turn into 240 volt AC to be able to pure sine, to be able to run grinders, etc. out on the farm and farm shedding, essentially, making it a mobile power station as well as a stock and fencing vehicle. There's a few additions to the vehicle, like the outputs for the 12 volt. Now the 12 volt was running out of a Sevcon, I believe, 48 volt to 12 volt converter, so 14.4 at 300 watts. So when you turned on a motor, e.g. the fencing control motor, it would be dimming the headlights to not be very bright. So in order to get around that, I'm exchanging it for another 48 volt DC converter that'll run off the 48 volt 400 amp hour pack, and that'll be trickle charging a 12 volt or 12.8 volt lithium ion pack through the BMS, and that was where the power will come from, and also be running the headlights off the DC and any other auxiliary 12 volt systems. But power control will be coming out of the 12 volt LiFo pack, which will be sitting under where the charger is now. So just in this section here. The new charger will be mounted there, which is a much more efficient and effective charger. Can be programmed. We'll have to get the dongle for that. But this is the Polaris Ranger with the ute tray taken off and the bonnet taken off to be able to access more electronic components. And next is this seating area and stuff coming out. I believe EV Power over in Perth have done one of these as well with their 12 volt 4S packs. I believe it had good results, but I don't have much more information of how they did certain things. So, and that was probably a few years ago, so technology hasn't changed that much, but it has changed. And methodologies coming from motorcycling and electric power knowledge. We're changing the way we do things, integrating solar charging and things like that. So we're going to put a halo light around the top here, so you have a bunch of switches so you can turn on the sides, rear or front lights for evening use or running lights or whatever. That's up to the client, but they will also be all 12 volt and light bar style scenario. So we'll be adding a roof rack which will have the panel mounted on it, and then all these light bars running off it. I'll call it a halo light because that's what I decided to call it. So let's have a bit of a talk around the video, and I'll just do another video so I can flip it around and have a chat about that. It didn't turn off.